All right, boys and girls, let's do this one right here. This is paper 2. It's from 2014. The reason I know it's paper 2, it says so right here. It also has a 21 right there. 0444 is the syllabus. That's the Cambridge IGCSE syllabus for United States. So look, when you take this, make sure you briefly read the front. It's almost always the same, but there are slight changes, and these can give you clues for how to answer questions on the test. So write in dark blue or black pen, right? So I got this. You can use a number 2 pencil for graphs and diagrams. All that. No calculators. 70 points. Let's do it. First page. Look at this. This is a formula sheet, a reference sheet. You might not have to use all these formulas. Sometimes it's the case. There's a formula in here for something you've never ever done. And it's going to ask you a question in the test that will require the use of one of these formulas. So, there we go. So let's get to it, right? All right, number 1 is at 1 minute. I'm writing the time, if I can put timestamps in there. Ooh, simplify. Man, all right. So look, first of all, the square root of 9/16 is 3/4. We're just going to say it's the plus, and then 2 to the negative 1 is 1/2. So that's 3/4 plus 2/4, right? Because 1/2 is 2/4. That would be 5/4. Now, I'm going to go through this kind of quickly as I can, and come back and grade it later. Okay, 130 for number 2. So find the value of y when x is 0.1. So 0.1 over 2 plus 0.1 squared. Man, oh, I hate this. These always make me feel so dumb. All right, because like this is basic arithmetic, right? Man, 0.1 squared times 0.1. So that'd be 0.01, I think, right? Because 1 times 1 is 1, but you've got 2 decimal places. So, yeah, 0.01. So, 0.1 divided by 2. Let's see, 0.1 divided by 2. All right, so let's see. Let's move that decimal place right here. 0.5. So I think it's 0.5 plus 0.01. I think that's 0.51. Oh, man, if that's wrong, it's going to be embarrassing. But something tells me this is wrong. I'm going to come back and check this one in a minute, okay? All right. 232. All right, solve the equation. Now this one I can handle. N minus 8 equals 22, so N is equal to 30. Make sure you write your answers over here, show your work. Okay. In the space provided, write each number, calculated correct to a single significant figure. So this is going to be 5 times 2, 20. So that's going to be 10 over 20, which is 1/2. Use your answer in part A to estimate the value of P, 1/2. There we go. So this was at about 3 minutes. All right. Saving this because we're going to do another video where we grade them, because learning how to use the mark scheme is kind of a big deal. All right, so 320. All right, so square this, so it'd be 9 times 2. That's 18. Let's see. We got to simplify these square roots right here. So this is 4 times 6. And this is 9 times 6. That's 5 square root 6. All right, Carlo. Oh, man, these always give me trouble too, right? Let's see here. Let me get some coffee. Oh, man, that's good coffee. All right, Carlo changed 80 euros into dollars. 150. Then he spent $88. He changed the remaining back into euros, and it was 160. Okay. So euros to dollars is 150. Sorry. Euros to dollars. This is the problem with pen, right? Is 1 euro is worth $1.50, right? Okay, so he had 80 euros. That would give him 120 euros. Okay. I got a pug over here making a mess. So it's 120 euros, and he spent, $120, and he spent 88. Right. So that should be 32. Right. 32. Now let's see here. I'm going to go ahead and 32. So he had 32. Then he changed it back, and it was 160. So 1 over 1.6 Actually, I'm going to do it the other way. 1.6 over 1 is 32. Oh, no, I should have done it the first way. So let's see here. I'm going to do it that way. Yeah. This one's upside down. This one's upside down. So 1 over 160 equals, we don't know how many euros, over 32. So 32 that's 20 euros. I think that's right. I'm going to come back and check this one too. All right, but here's the thing I messed up on this, and this is what I want to make you aware of. So you have your ratio A over B equals, like, I don't know, whatever's related, right? You want to put your unknown on top. And here I had my unknown, here I had my unknown in the denominator. You see, you want your unknown in the numerator. So, yeah, kind of messed that one up. But that's okay. That's right. All right, next up, Buttercup. Moving onward. Number 7, which is going to be at 6 minutes and 2 seconds. Okay, number 7, solve for x. I can handle this. Show you work. Take the square root of both sides. So I would say 4 plus 1 minus 6. So you're going to add 4 to both sides, right? And I put the 4 first, so you don't have to worry about writing it incorrectly. All right. Onward and upward. Numero 8 at 6:30. All right. Ooh, write the fraction in the simplest form. Oh, these are tricky. Look, our common denominator for this is going to be x times x plus 1. The mistake everybody always wants to make, they want to put a plus 1 right here, but you can't get a common denominator with addition or subtraction. It has to be multiplication. Lowest common multiple of x and x plus 1 is their product because they are relatively prime. So we have to multiply this one by x over x. We have to multiply this one by x plus 1 over x plus 1. So that's going to give us 2x plus 2 right here because we have to distribute that 2. So 2x minus 2x is 0. So there's our answer. All right. Numero 9. 7:15-ish. Okay. A bus company in Dubai has these following schedules. That's 24-hour time. All right. That's its operating time. So start and finish and the day of the week. Calculate the total number of hours the bus company operates in 1 week. Well, in 24-hour time, this is actually a little bit easy. So this is 11 hours, and these are all 18. Are they all the same? So we have 1, 2, 3, 4, 5, 6 times 18 plus 11, right? That's 11, right? All right, so 108 plus 11 is 119 hours. Let me make sure. Let me see. 18 and 6. Oops, times 6. Yeah, 108. Okay. And then it says, write the starting time on Friday in a 12-hour clock. So that would be 12-hour clock needs the PM, you see? All right. Onward and upward. Ooh, we got some probability coming up. I think I remember this problem as being kind of tricky. All right, but number 10, first of all. This is at 8:20. So, factor. We have 4 terms. That's factor by grouping. You see how we can take an a out of these and a b out of these? So a, x plus y. Now you see how these two things are the same? Oh, dang. That's pretty fancy right there, isn't it? All right. Had to check on the plug again. He's being naughty. All right, now look at this next one right here. You see how I have x minus 1 and x minus 1? We can factor out an x minus 1. Do you see? And we're left with 3 x minus 1 plus 1. See, that works because if you distribute x minus 1, the whole thing, to here you get x minus 1 squared. Here you get x minus 1. Right? So let's go ahead and let's see if we can clean this up a little bit. So this is going to be 3x minus 1 plus 1. X minus 1. So then, let's see, we're factoring completely. So we're just going to finish this. That makes 0, so we have x minus 1 times 3x. Oh, no, I made a mistake. 3x minus 3. Look at that. I almost messed it up. 3x minus 3. So, x minus 1, 3x minus 2. My bad. Glad I caught it. Stupid pug distracted me. All right, number 11. 9:45. Oh, let's get some coffee, get this thing started. Oh man, weighted probabilities. I haven't done these for like a long time, so I'm trying to remember how this goes. I see that right there. So bag A is 2 white, 5 black. Black B, 1 white, 5 black. Alex chooses a bag and then chooses a bead at random. Now the probability he's going to choose bag A for some reason is 1/4. Find the probability that he chooses a white bead. So there's 2 ways to choose a white bead, right? You could choose bag A, which is 1/4, right? So he's got a 1/4 probability he chooses that. If he chooses that, he has a 2 out of 6 probability. I think this is right, and then a 1 out of 6 probability. I think this is the correct way to do this problem right here. It's been a while, these weighted probabilities, because it's not just a straight up probability. Like there's a weighted probability he chooses this bag or this bag. So anyway, let's do this right here. So that's a 1/12 plus 1/8. Is that right? Yeah, that's right. So 1/12 plus 1/8. So those have a common denominator of 24, I would believe. So that's going to be a 3, a 2, 5 out of 24. 5 out of 24. All right, we're going to see if I get that one wrong. Oh, man. Okay, we'll come back to that in just a second. Number 12 starts at 11/24. Okay. Scientific form. So scientific notation. So P times Q, PQ, P times Q. So that would be 4 times 10 to the 5th times 5 times 10 to the 4th. Oh, man. So that's going to be, so check this out. That's going to be 20 times 10 to the 9th. Do you see? This is all multiplication, right? So you can multiply those integer parts first, and then 10 to the 5th times 10 to the 4th is 10 to the 9th. So that's 2.0 times 10 to the 10th. Yep. Okay, Q divided by P. So okay, so 5 divided by 4 is 1.25, right? Let's see, 5 divided by 4. I just want to make sure. Something seems weird right here. Okay, 2 and then 8, 2, yeah, 1.25. I got it right. Okay, so this is 1.25 times 10 to the negative 1. You see? 10 to the negative 1. Because you subtract those and you get, yeah. So I think this is it right here, 1.25 times 10 to the negative 1. All right, well, let's roll with this one. Oh, man, a circle problem. This is going to start at about minute 13. All right, so let's see here. We've got center is O, so that means this is what I always mess up with center. These are equal, so we have some isosceles triangles in here. Looks like we also have a cyclic quadrilateral. We got a central angle. We got an ascribed angle. Okay, got a lot of stuff going on here. All right, so let's see here. We got 23, 58. Doesn't tell us anything else. So OCA. OCA. So this angle right here. Wow, that's interesting. So if this is 58, this one has to be double of that, right? So the inscribed angle is half of the central angle. So that would be 58 times 2 is 116. So this was right here is 116. And it's isosceles, so I have to subtract that. So that would be 64, 32 degrees, I would imagine. All right, let's see here. DCA. So DCA, that's a tricky one here. 23. All right. Let's see. How are we going to figure that one out? Oh, I see. Well, CDAB is a cyclic quadrilateral, so these two angles are going to be supplementary. If I can figure this angle out, I know that in this triangle, this is 23, so I just subtract from 180, right? So that's 122, right? So, because, like, let's see here. I'll do my work over here. 180 minus 58 is 122. 122 plus 23 is 145 minus 180 is 35 degrees. I think it's 35 degrees. We're going to grade this one in a minute, see how I do. Man. Okay. We got the 0.510. up here and the point negative, or 13, -2 over there. All right. And we've got a perpendicular bisector. So that means this side and this side are equal to each other. And this AB has a slope of 2/3. Find the equation of the perpendicular bisector. So here's 2/3. So I know the slope of this one's -3/2 because it's going to be the negative reciprocal, right? So here's what we need. We need y equals mx plus b. And I know that that's -3/2. But I don't have any points. But I can figure this out because it bisects these 2 points. So this is the midpoint of 5, 10, and 13, 2. Midpoint is the sum of the x's divided by 2 and the sum of the y's divided by 2. So this is going to be the x's are 5 to 18, 5 to 13, which is 8. So that's 9, or 18, which is, here, watch. 5 plus 13 over 2. That's my x coordinate. 10 minus 2 over 2 is my y coordinate, so 4. So this is 9, 4 right there. So now I know that y equals 4 when x equals 9. Oh, that's not very nice. That's not very nice at all. X is 9. And, yeah, 4. Okay. Let me make sure I got this right. Oh, wait. Ooh, I almost messed up. Look at this. The perpendicular, this slope. This line has a slope of 2/3. Here's what made me pause. This is a paper 2. The numbers always work out easy. This would not work out so easy. I mean, it's not difficult, but that's what made me pause. Is I like, well, wait a minute. This is just so much of a coincidence because if it was 2/3, this would reduce. So here's what I've got. It makes sense too. This is positive, right? It's not the scale, but that's going up. -3/2 would be this one. Going down. All right. So there we go. Oh, man. So 4 equals 6 plus b. So -2. 2/3x minus 2. There we go. Oh, man. Okay, number 15 is at 1720. All right, number 15. Ooh, find positive integer values of x. Look, here's the key right here. Positive integer values of x. Now we have two x's here. So we have to multiply by 5 to get the fraction gone. Make sure you distribute correctly. Now I'm going to move 4x over there. And, sorry, 16. So 4 is greater than x. So x is less than 4. You see positive integer values. So that would be 1, 2, 3. 0 is not positive or negative, and it's less than 4, so it's 1, 2, 3, I think. That's a 4-point question right there. Dang. Okay, find the value of p. This one's going to be at 1805. Okay, find the value of p. So 24, 2 to the power 24 to the power 1/2 equals p to the 4. Wow. So I need to get this to be a 4, I think. So this is going to be, I'm going to go ahead and distribute that. It's going to give me 2 to the 12th equals p to the 4th. Okay. Now look, would you guys agree with me that 4 times 3 is 12? Right? 4 times 3 is 12. So look, these two things are equal to each other. Right? That's 12, right? The reason I did that is because if I can get these exponents to be equal, then the bases are going to be equal. So 8 or 2 to the 3rd. Either one. You don't usually put multiple choice answers there, but all right, I probably should do that. Just leave it 8. All right. Simplify. So 2q, or q squared plus q squared, q to the quarter times q to the quarter. So that's going to give me 2q to the power of 2. It's tempting to add those exponents, right? But that's just something plus itself. Now, we do add these exponents, q to the quarter, that gives me q to the 1/2. Would you guys agree with me there? Right? 1/4 plus 1/4 is 1/2. And the bases are the same, and multiplying, add the exponents. Okay, now, we have to subtract 1/2, 2. We have to subtract 1/2 from 2. So here's what we're going to get. We're going to get 2, the power of q, and that's going to be 3/2. 2 to the power of q, 3/2. Let's see, look, 2 minus 1/2. That's 1.5, which is 3/2. All right, yeah, we're going to leave it there. All right, moving on. Wrong or not? All right, let's see here. Number 17 starts at 1955, approximately. So let's see. A travel brochure has 72 holidays in 4 different countries. A pie chart shows this information. There are 24 holidays in Thailand. All right, I don't know if that's good or bad. I don't know how many we have in the U.S. Well, Thailand. Ooh, Malaysia's got quite a bit. All right, so show that. So there are 24, and show that the sector angle of Thailand is 120 degrees. Okay, so let's see here. 72 total holidays. 72 total holidays and 24. So 360 360 degrees. Sorry, 300, it's just divided by 72. 360 degrees is the whole thing. There's 72 of them, right? All right, so then I know the 72 should go into 360 evenly. We can't use a calculator though, right? Oh man, so this is 60 times 6, and this is 6 times 12, so that reduces 5. Each one is 5 degrees. All right, so then there are 24 holidays times 5. Let's see. Oh, duh. Carry 2, 120. Okay, there we go. 120. So this is this work and this work combined. There you go. So this is, yeah, I think that's pretty clear. So 5 degrees per holiday. That's what that shows, right? 24 days times 5 degrees. So I'm just trying to put notes there for if somebody was grading it for me, all right? Malaysia has 150 degrees. The sector for Singapore is twice of Hong Kong. Oh, that's interesting. Okay. So this is 120 degrees. 120 degrees. Singapore is twice of Hong Kong. So whatever Hong Kong is, Singapore is twice as big. Calculate the number of days in Hong Kong. All right, so these make 270, right? So together, these two, Thailand and Malaysia, make 270. So subtract that from 360, looks like we have 90 degrees left, right? So that means that, right, X is 30, so Hong Kong has 30 degrees. 30 degrees 30 degrees divided by 5 degrees per holiday is 6 holidays. That sounds terrible. 6 holidays? Nah. That doesn't sound very nice. 6 holidays. That's no bueno. I don't think I want to move to Hong Kong. That doesn't sound very good. All right. 23 minutes for number 18. All right, this one's kind of a tricky one. We're starting to get into some geometry. A solid cone has a radius, has a base that's a radius of 4 centimeters and a height of 12, and it is a right cone. Diagram says so. Mathematically similar cone, that means that they're proportional, is removed from the top. The volume of the cone that's removed from the top is 1/8. That tells me that this is going to be a distance of 6 already. I'll tell you why. The scale factor for volume is 1/8. Scale factor volume is cubed. So that's cube root. So that means the distance, oh man. Okay, that's good. So explain why the cone, explain why the cone that is removed has a radius of 2 and a height of 6. The scale factor for volume is 1/8. So the linear factor cubed is the volume factor. The volume, that's not the right way to say it, right? So then, so I think that's sufficient. Yep. Okay. Ooh, interesting. The volume of the remaining solid is K pi cubic centimeters. Find the value of K. Ooh. Remaining. So I think that means this bottom part. I mean, let's see, because this is the part that's confusing me. The volume of the remaining solid. Okay, so it says that, yes, that the top is removed, right? So check this out. Picture diagram. Good. So if this is 12, and that's 4, right? If that's 4, and this is 12, that's the entire thing. And if you subtract, right, 6 and 2, then what you have is your truncated base. So that's a really ugly one right there. Oh, man. All right, so anyway, this is 1/3 pi r squared h. And I remember that, but I'm going to check anyway. So I'm going to get my formula sheet out right here just to make sure. Volume of a cone, the radius of r and a height of h is 1/3 pi r squared h. So we work good there. So 1/3 pi r squared h, and then minus the other 1/3 pi r squared h is going to be our answer. So look, here's what I would do. I would do pi over 3 times 16 times 12 minus 4 times 6. Do you see? Here's why I did this. Here's what I did. 16 times 12, because the radius squared is 4 squared is 16. Height is 12. Radius is 2, squared is 4, times 6. Height is 6. And then times pi over 3. All right, so now I'm not going to distribute that pi over. Yeah. Let's see. Check this out. Look, this is a paper 2. No calculators involved. You see that 3? It's going to reduce. So that 3, this is 24. Would you guys agree with this? This is 24. So that 3 reduces with that to make 8, and it reduces with the 12 to make 4. So 64 minus 8. 56 pi. Is that right? I think that's right. 56 pi. No. 56, because it's just k. 56. Oh man, that's a tricky one. Not sure. Man, my I'm not 100% confident with my calculation on this one. Let me double check real quick. So here's what we've got. We've got 16 times 12 minus 4 times 6, and that's going to be times 1/3 pi. So that's pi r squared h, right? And 1/3 of that. So then I reduce that to 4, and I reduce this to 3, right? This is, or 8, I mean, 8, because it's 24 divided by 3, and then 64. Yeah, that's right. I think it's 56. Oh, man, we're going to find out in a minute. Okay, last one, number 19, is at 28 minutes approximately. Ooh, oh, man, this is a tricky one. This is a 7-point problem. That's a 1/10 of the test. The test is worth 70 points. So this is a big one right here. So showing work. Man, showing work on this one's going to be massively important, okay? So we get this diagram. It's a rectangle, it tells me. That means this is 90, 90, 90, 90 everywhere, right? D lies on EC. So EC, so D is the point on EC. DAB, a sector, radius 8. Oh, so we have a sector in here, even though it's kind of in the triangle. And the angle is 30. Find the perimeter of the shaded region in form a plus b root 3 plus c pi. Oh, that's tricky. Well, all right, let's start breaking this down, okay? We have to find this thing right here. So look, here's what we know. Let's draw a picture diagram. Here's what we got. We have to find these distances right here. So we have to find DC, CB, and the arc dB. Okay, so the one thing we know for sure, let's see here. Ooh, hold on. Oh, we got to find, man, we got a lot of stuff to find right here. All right, so check this out. Let's start off by finding this part right here. Let's find this distance. Let's find CB. Okay, so DC plus CB plus the arc dB. All right, let's start off with CB. So look, CB is going to be the same as AE. Would you guys agree? Because it's a rectangle, right? So the opposite sides are going to be congruent. What we have right here is we have a 60, a 30, 60, 90 with like this right here. So look at CB right here. Look, here's what we've got. Let's see, I'm trying to figure out where to draw this. Let's draw it over here. So here's what we've got. I don't want to mess up the... All right, so we have a 8, right? That's our hypotenuse. We have a 60. So the short side is 4. So and the other side would be 4 root 3. Yeah. So here's how I remember that. Look, for 30, 60, 90, the short side, which is, if this is 30 degrees right here, the short side is the opposite of that, and that's half of the hypotenuse for 36, 90. And this is 4 root 3. Do you see? From E to D. So this, CB, is 4. That makes life easy. So I'm going to say A is 4. I'm going to say right off the bat A is 4, but maybe it's going to combine with something else, so we'll wait for that. Now DC, look at this. DC is going to be the whole thing right here. EC, right? Would you guys agree with this? Here, let me say this right. DC is equal to EC minus ED. Would you guys agree with that? DC, this part, is going to be equal to the whole thing minus this part. Well, isn't the whole thing EC 8? And that part's 4 root 3. So this is 8 minus 4 root 3. Look at that. Okay, now, the sector dB. Well, that's 30 out of 360. That's 1/12 times pi r squared. No, 2 pi r. 2 pi r. And r is 8. Right? So this is going to be 1/12 times 16 pi. So that's going to be 4/3 pi. Right? Because that reduces 4/3 pi. Plus 4 plus 8 minus 4 root 3. Do you see how my picture, my picture, and then I put all my stuff here? Oh, I'm sorry, you couldn't see what I was writing. Sorry, my fault. So here's what I did. Let me back up, okay? dB, the sector. So we have 30 degrees out of 360. We have 30 degrees out of the whole circle. And we're looking for this part, right? The perimeter, which is 2 pi r, and r was 8. So that's 16 pi. That's 1/12. 30 out of 360 is 1/12, so that reduces to 4/3. Yep, so let's combine these two right here. 12 minus 4 root 3 plus 4/3 pi. Now this is in the correct order because it says right here, the A plus B root 3 plus C pi. Now, I don't know how I did on this. I don't know if I got a good grade, bad grade, whatever. There will be an additional video where I go through this whole paper and grade it, and I'll put my score there. I'm sure I did not get 100 because, man, mistakes. All right.